Hey everyone, and welcome. So let's talk about something that I guarantee every C# developer has hit a wall with at some point. You need to access a private method from outside its class. It's this classic dilemma, right? You're stuck between the rules of good design and a very real practical problem you need to solve. And that's exactly what we're going to dive into today. I want you to picture this. You've just built this awesome, clean class. Everything's tucked away, perfectly encapsulated. But there's this one super important piece of logic, maybe a tricky calculation that's hidden in a private method. And for whatever reason, a unit test, some weird legacy system you have to connect to, you absolutely need to call it from the outside. It feels like you've been locked out of a room in a house that you built. So how do you get back in?
Now, before we start trying to pick the lock, we really need to understand why that lock is there in the first place. You should think of it less like a brick wall and more like a velvet rope at some exclusive club. It's there to protect what's going on inside.
And that velvet rope, well, it has a name: encapsulation. It's one of the absolute cornerstones of object-oriented programming. It's basically a contract that your class makes with the rest of the world. It says, look, you can use my public stuff, don't worry about how I do my job internally. I've got it covered. This is huge because it means we can change the internal wiring of our class without breaking everyone else's code. Yeah, that's the ideal world, right? But in the real world, sometimes you have a really good reason to step over that rope. The number one reason? Unit testing. How are you supposed to properly test a complex private method if you can't even call it? Or maybe you're stuck working with some old library that you just can't change. You need access, and you can't just rewrite the whole thing. Okay, so let's talk about the first and by far the most powerful tool for getting past that rope. This is the master key, the universal lock-picking kit of the C# world. It's called reflection. It lets you inspect and even manipulate your code while it's running. It's incredibly powerful and also a little bit dangerous. The whole process sounds kind of magical, but it's actually pretty logical when you break it down. First, you grab the type of your object. Think of it as its blueprint. Next, you ask that blueprint for the specific method you want, but, and this is the key part, you tell it, hey, look in the private drawers too. And finally, once you've got a handle on the method, you just tell it to invoke on your object. And this is what it looks like in practice. See that binding flags.nonpublic? That's the magic password. That's what tells the system, I know this is off limits, but I need you to find it anyway. Once you have that, you can grab the method and invoke it, unleashing whatever logic was locked away inside. And this brings us to the big trade-off. On one side, reflection gives you almost godlike power. You have total access to anything and everything. It's why a lot of big frameworks use it. But the downside, it's a big one. Reflection is slow. Way slower than a normal method call. And even worse, it's super brittle. Your code relies on the method's name being a string. The second someone refactors and renames that private method, your code just blows up at runtime. The compiler can't help you. So if reflection is like picking the lock, what if there was a more official way to get access? What if you could just get your name put on the VIP list? Well, you can. It's a feature called friend assemblies. The magic here is an attribute called InternalsVisibleTo. With this, you're creating a formal agreement right at compile time between two of your projects. You're basically telling your main project, hey, see that other project over there? That's my testing project. It's cool. Let it see all my internal stuff. It's a much safer, sanctioned way to grant access specifically for things like testing. And check out how simple it is to set up. You literally just add this one line of code. usually in a file called assemblyinfo.cs. You name the friend assembly that gets the VIP pass, and boom, you're done. Now your test project can see and call internal methods, but to the rest of the world, they're still locked away. It's the best of both worlds.
Okay, let's switch gears. What if you actually do have control over the original class? In that case, you don't need to break in from the outside. You can just build a secret passage from the inside. There are a couple of really clever design patterns for this.
First up is the nested class. There's this really cool rule in CSharp that says a nested class gets full access to all the members of its parent class, even the private ones. So you can just create a tiny public class inside your main one to act as a little gateway, exposing just that one piece of private functionality you need in a totally controlled way.
Another really slick way to do it is with delegates. You can think of a delegate as a type-safe remote control for a method. You can create a public delegate, and then inside your class, you point that delegate to your private method. Now, anyone outside can press the button on the delegate, and it'll run your private method indirectly. You're exposing the action without ever exposing the method itself. Pretty neat, huh?
So, we've just looked at some seriously powerful techniques, from the brute force of reflection to the elegant little tricks with delegates. But this is where we have to take a breath and remember that famous line, with great power comes great responsibility. And you don't just have to take my word for it. The source material for this explainer puts it perfectly. When you violate encapsulation, you're creating code that's tightly coupled, making it a nightmare to maintain and change down the road. You're creating a fragile dependency on how a class works on the inside, the very thing encapsulation was designed to save you from.
So before you use any of these tricks, please ask yourself these questions. Is there a better way? Could I just refactor the code so I don't need to do this? Is there maybe a public method that already does what I need? You have to understand that needing to access a private method is often a code smell, a symptom of a deeper design problem. And while treating the symptom is easy now, fixing the design is always the right call in the long run.
At the end of the day, you have the keys to the kingdom now. You know how to pick the lock with reflection, how to get on the VIP list with friend assemblies, and even how to build your own secret backdoors. But the real challenge, the mark of a truly great developer, isn't knowing how to do it. It's knowing when. So I'll leave you with this question. When is it truly the right move to break the rules?